In this lesson, we're going to be focusing our attention to these three rules: the sine, cosine, and the area rule, right? The area rule. From level 2, I'm sure that you have done this, something called SOHCAHTOA, right? And the SOHCAHTOA was only applied to a specific triangle, only the right angle triangle, right? So SOHCAHTOA, what I'm trying to say is that it only applies to a right angled triangle. A right angled triangle. It only applies here. So the SOHCAHTOA sine opposite being sine being opposite over hypotenuse, cos being adjacent over hypotenuse, and tan being opposite over adjacent. So these ratios, they only apply to a right angled triangle. So with the cosine, sine, and area rule, we are trying to expand that to other triangles, right? To other triangles. As we know that trigonometry is what? Is the relationship or a branch of mathematics where we study the relationship between angles and the sides in any given triangle, right? But with the SOHCAHTOA, you can only apply it to a right angle triangle. So sine, cosine, and area rule, it's not limited to only the right angle triangle. You can also apply to other triangles. Okay, this is very crucial. Yes, this is very, 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 very important, because when it comes to solving problems involving triangles and you have to calculate unknown sides, right? You you need to understand what type of rule to apply. Is it the SOHCAHTOA? The SOHCAHTOA only applies to a right angle triangle, and then for the other type of triangles, you can only apply the sine, cosine, or the area rule. So in this lesson, we're going to be discussing each of these rules, okay? But just a quick recap. Let's go back to the concept of the SOHCAHTOA. So here's a right angle triangle, okay? Here's a right angle triangle. So in this case, I have three things that are unknown. I have this angle that is unknown. I have this hypotenuse AC that is unknown. I also have the BC as unknown. Okay, so just a small activity that we can use to remind ourselves how to actually apply the SOHCAHTOA to a right angle triangle before delving into the rules. Okay, so we're gonna start off by calculating the angle A. Okay, so I'm given a triangle, a right angle triangle. I know what angle B is. I know what angle C is. Angle A is the third angle in this triangle. So how can I calculate A? By using the sum of angles in a triangle. So here's the solution here. So the solution to this is going to be what? Number one, A can actually be calculated as being equal to 180 degrees subtracted by 90 degrees, this angle, minus 36.87 degrees, this angle, right? I'm subtracting from 180 degrees because the sum of angles in a triangle equates to 180 degrees. So angle A is equal to, you know what, let me use this calculator. Let's use this one. Okay, so it's 180 subtract 90 subtract 36.87. I'm getting a 53.13 degrees. So this is angle A. This is angle A. Now, the next task, the next question is asking us to calculate what? BC. They want us to calculate BC. BC. Okay? So, here we're going to have to apply SOHCAHTOA, right? You can work with the angle C. You can work with the given, right? You can work with the given values or the values that that are available in the sketch. So I have the angle C. I also have the angle A, right? So in order to apply the SOHCAHTOA, you need to reference an angle, right? I'm gonna choose angle C in this instance. Okay, so I have an angle C as well as this side AB. I want to use this information to calculate what? BC. Okay, so me referencing angle C, that makes side AB opposite to this angle, and that makes what? The unknown side BC the adjacent side, right? So this is the angle that is being referenced. BC is the adjacent side. The 3 length AB, that is the opposite side. So you need to ask yourself, which trigonometric ratio, according to the SOHCAHTOA, has an adjacent side and an opposite side? It's obviously what? Tan. So in order to calculate what BC is, I'll have to use the tangent function. So I'm going to say tan of the reference angle, which is 36.87 degrees, is going to be equal to what? According to SOHCAHTOA, it's what? It's opposite over adjacent. The opposite side is AB. So it's going to be AB over the adjacent side. It's what? It's BC. It's BC. So I'm going to have a tan 36.87 degrees is equal to, let's substitute. I have a 3 over BC, the unknown. So I'm going to calculate BC. So I'm going to have to divide on the left hand side by a 1 so that I have a fraction and cross multiply. So BC multiplied by the tan, I'm getting a BC tan 36.87 equal to 3 times 1, that's 3. Then in order to get the BC, I'll have to divide both sides by 36.87. Tan 36.87. Cancel, cancel. BC is now what? 3 over tan 36.87. I'm getting a 4. I'm getting a straight up 4. So BC is what? 4 centimeters. Okay? 4 centimeters. Or you can reference what? Angle A and work out what BC is. Right? And work out what BC is. And then for the third question, they want us to calculate what? AC. Well, now we have more information available, right? We have the length for this side, we have the length for AB, we have the angle C, we have the angle A. I now want the hypotenuse AC. How do I calculate the hypotenuse? I can either use the Pythagoras theorem, right, to calculate the hypotenuse, or I still have the option of applying SOHCAHTOA. Okay, so you know what? Working with Pythagoras theorem, okay, that's an easy task, right? You can go ahead and say AC squared is equal to BC squared plus AB squared. You have BC, you're going to substitute. You have AB, you can substitute. Then calculate the value for AC. You can do that. That's easy, okay? But what I want us to do is use SOHCAHTOA to calculate the hypotenuse. So for number 3, I want the value for the h, the hypotenuse. It's the unknown in this case, okay? Again, I'm going to reference this angle, right? This is going to be my reference angle. So since 36.87 is our reference angle, who's the adjacent side? Who's the opposite side? So this is the reference angle. The BC is still our adjacent side. you know what, let's make things a little bit interesting. Instead of referencing the same angle over and over, how about we work with angle A this time around? 53.13. So this angle A is now our reference angle. Let's work with that. So if 53 is the reference angle, that makes AB the adjacent side and the BC the opposite side. Okay? But I want the hypotenuse, right? I want the hypotenuse. Let's say I'm referencing A and working with the opposite side, BC, the length we just calculated, BC. Okay? I'm referencing this angle. I have, or I'm working with the opposite side. I want to calculate the hypotenuse. So I need to ask myself, which ratio can I use to calculate H that has the hypotenuse as well as the opposite side? Which one is that? That is sine. Okay, so I'm gonna say sine 53.13 is equal to opposite. Opposite is the 4 over the hypotenuse, which is AC. Divide both sides by 1. Divide by 1 on the left hand side, cross multiply. AC multiplied by the sine 53.13 is equal to 4. Then we divide by the 53.13, sine 53.13. Cancel. AC is equal to 4 over sine 53.13. Answer syntax error. I think it wants me to close this bracket. Here we go, 5. So the hypotenuse is what? Is equal to 5. Okay, so you applying the Pythagoras theorem to work out what AC is, you should be getting a 5 as well. Okay, a 5 as well. So with the SOHCAHTOA, you need to use what is given to calculate the unknown. Just make sure that whatever ratio you pick from the SOHCAHTOA, it has the unknown. It should have only one unknown, right? And then the rest should be given, like we did here. This angle was given, this was given, only AC was unknown. Okay, only AC was unknown. All right, so this is SOHCAHTOA, something you did in high school as well as in level 2. But now here's an interesting case. I have triangle ABC. Clearly this triangle is not a right angle triangle. Okay, so maybe let's say you are given something like this and they want you to calculate, I don't know, maybe they want you to calculate angle B, angle C, as well as maybe the length AB, right? As well as the length AB. So how do you go about finding these unknowns? SOHCAHTOA is not going to work. It's not a right angle triangle. That is when the sine, cosine, and the area rule come into the picture. So the sine rule can be used for finding an angle or an unknown side. Same applies with the cosine rule. Can be used to find an unknown side or an unknown angle. The area rule is a rule or a formula that can be used for finding the area for any triangle, provided you are given 2 sides and 1 angle, right? So let's take it one step at a time. Okay, we're gonna address this. We're gonna address these unknowns, right? We're gonna address them, but for now let us talk about the first rule in question. So we're going to talk about the sine rule. We're going to discuss the sine rule. So the sine rule, basically what it does, it's basically a ratio between a side and the sine of its opposite angle. Okay, let's say maybe we assign some angles here. Let's assign alpha as the angle at vertex A and beta as an angle at vertex B, and I don't know, let's place theta here as an angle at vertex C. So sine rule says if you take a B, this side, and divide it by the sine of its opposite angle, that is theta. You take a B and divide it by the sine of its opposite angle. This is going to be equal to AC divided by the sine of its opposite angle, which is beta. And then I can say the same thing about BC over the sine of its opposite angle, which is alpha. So when you take a side and divide it by the sine of its opposite angle, the same is true, or it's going to be equal to the other ratios where you take the side and divide it by the sine of its opposite angle. Or you can also write sine like this. Sine theta over AB sine beta over AC sine alpha over BC. This is also true. Okay, now let's go back to the problem we had, right? The problem we had just now. Okay, I screwed up. Let me just erase this. Okay. All right, no problem. I just want to show you how to apply the sine rule. So let's just erase this part and this part, and then let's go back to this problem we had, right? Now we want to calculate what? BC. We want to calculate angle B, angle C, as well as the unknown side AB. So we know that sine rule says what? If you take a side and divide it by the opposite, if you take a side and divide it by the sine of the angle opposite to it, it's going to be equivalent to the other sides divided by the sines of the angles that are opposite to the respective sides. Okay, so check this out. So applying sine rule to this triangle, I'm going to start off by calculating the angle B. So I'm going to say sine angle B divided by its opposite angle. So it's going to be divided by what? 4. And then I'm going to equate this to sine 30 degrees over 2.52. Okay, so what you need to do is the following. You take the sine of an angle and divide it by its opposite side, the side that is opposite to that angle. And then you take the sine of B and divide it by its opposite side, right? So you want to take ratios where only one is unknown, right? So I could have said, how about we take sine angle C divided by AB and say equal to sine angle B divided by 4. Now there's a problem. I have 1, 2, 3 unknowns for this equation, right? You need to take ratios where there's only one unknown. That is why I went with sine B over 4 and sine 30 over 4. This is given. Oh, also the angle opposite to this side is also given. So I need to take this ratio. Now, B is what I want to calculate. Oh, the opposite side is known, right? So by using or taking these two ratios, I now have only one unknown, which is the angle B, right? So what I can do next is cross multiply. So I'm now going to have a 2.52 sine angle B is equal to 4 multiplied by sine 30 degrees. Divide both sides by 252 over 2.52. This cancels this. I'm now left with a sine B equal to so 4 times sine 30 degrees over 2.52. Okay, it's 0 0.793 650. Now to calculate the angle B, I'm gonna say angle B is equal to arc sine 0 0.793 650. So angle B is now equal to shift sine 0 0.973 650 equal to, so angle B is 52.528 degrees. 528 degrees. So inside this triangle I have two angles that are known and one unknown angle. This allows me to calculate angle C using what? This allows me to calculate angle C using sum of angles in a triangle. So angle C is just going to be equal to 180 minus 528 minus the 30 degrees. Angle C is equal to 180 minus 52.528 minus 30 degrees. 97,472 degrees. Okay, 572 degrees. Now I have the angle C, that's 97.472 degrees. Okay, so the sine rule tells us that we have three ratios. We have three fractions that are equal to each other. So when you perform calculations, you only need two, right? You need only two. The sine of the angle over the side, or the side over the sine of the angle. You can do it that way. Okay, so now we want to calculate AB, right? I want to calculate AB. So AB is unknown, but opposite side is known, right? So I can use this and this because it's known. The side is known and the opposite side, the opposite angle is also known. Okay, so since I want to calculate AB, I'm just going to say AB over the sine of the sine of the opposite angle, which is angle C. So that's 97.472 equal to 2.52 over sine 30 degrees. Cross multiply. Then AB, it's going to be multiplied by sine 30 equal to 2.52 multiplied by sine 97.472. Divide both sides by sine 30, sine 30. Then AB is equal to 2.52 multiplied by sine 97.472 close bracket over sine 30 degrees equal to, that's 4.997. okay, centimeters. This is our answer. This is how you apply the sine rule to get the unknown side or an unknown angle. Now, let's perhaps apply the sine rule again, once again, on this problem. So solve the following triangle. It's not triangles. Triangle using the sine rule and sum of the angles. It should be angles here. Angles in triangle. So I have a triangle ABC in which A is given. Angle A is 45 degrees. I also have BC that is 25 and AB that is 11. So I want to calculate angle C first, right? So I'm going to take the 11 and divide it by the sine of this unknown angle, and take the 25 and divide it by the sine of this 45. Yes? So you need only two ratios. You need only two fractions and equate them. Just make sure that there's only one unknown. So for number one, we're going to say sine angle C over the opposite side of the sine angle C, which is 11, equal to sine 45 degrees over what? Over 25. Then let's calculate C. Cross multiply. I'm going to have a 25 multiplying a sine C, 11 multiplying a sine 45 degrees, divide by 25, divided by 25. So sine angle C is equal to 11 multiplied by sine 45 degrees over 25. So the answer is 0.311. Shift sine of 0.311 gives me a angle C that is 18.120 degrees. So I have angle C. Angle B, I can calculate this using what? Sum of angles in triangle. So for the number 2, I'm going to say 180 minus 18.12 minus the 45 gives me angle B as 180 minus 18.12 minus 45 equal to 116.880 degrees. So this is the angle B. Now for the last one, number 3. This also brings us to back to the sine rule. Okay, the sine rule. I want to calculate what? AC. I want to calculate the AC. So it was important for us to know what the angle B is, right? So I'm going to say AC, the unknown, over the sine of the angle that is opposite the side, which is B, angle B. So that's sine 116.880 equal to, I can take this and that as my given. So I'm going to say 25 over sine of 45 degrees. Therefore AC becomes sine 116.880 multiplied by 25 over sine 45 degrees. This is after doing the cross multiplication thing, right? Now I have sine 116.880 multiplied by a 25 over sine 45 degrees. So AC is 31.535 centimeters. This is our answer. This is how we interact with the sine rule. Okay, now I want to bring your attention to the cosine rule. Okay, the cosine rule. So for the cosine rule, this is the cosine rule. The cosine rule. So maybe let me color code this. Let's work with purple. So this is how the cosine rule works. Let's say maybe you are given this angle. This angle, let's call it alpha, right? You are given this angle alpha. In order for the cosine rule to work, right? So the cosine rule, what it does, if you are given this angle, you'll be able to calculate the opposite side, right? You'll be able to calculate the opposite side. Or maybe let's say you were given this angle as theta. You were going to be able to calculate the opposite side. Or in a different setup where we have angle beta here, cosine rule allows you to calculate the opposite side. But when you are given this angle beta, for instance, you should be given the lengths of the sides adjacent or between the given angle, right? So here I'm given beta, I should be given this side as well as this side in order to calculate AC. So AC, according to the cosine rule, is AC squared equal to BC squared plus AB squared minus 2BC multiplied by AB multiplied by the cos of the given angle, which is beta in this case. Now, let's look at it this way. What if you were given maybe alpha? It means you should be able to calculate the opposite side. Let's take the purple away. You should be able to calculate AB, right? You should be able to calculate AB. You are given this angle. It means that you should have length AC. You should also have length BC. So number 2, the AB can be calculated as AB squared equal to BC squared plus AC squared minus 2BC AC multiplied by the cos of the given angle. Now for the last one, 3. Now let's say we were given this angle. Let's call it theta, right? You should be able to calculate the opposite side, but you should be given this side as well as this side. Okay, so BC can be calculated as AB squared plus AC squared minus 2AB multiplied by AC multiplied by the cos of the given angle, which is theta in this case. Okay, I think this formula, like the rest of the formulas for this discussion, they are better understood when applied. So let's take an example. You see what's happening here? They want us to solve the following triangle using the sine rule and the cosine rule. Alright, I wanted to mix it up a little bit, but you know what? We're just gonna stick to, we're gonna have to apply the sine rule. I remember now. We're gonna have to apply the sine rule. But the main character for this discussion is the cosine rule. I want to show you how to apply the cosine rule. And we're also going to use the sum of the angles of a triangle. So the solution here, number 1, we're going to have to calculate MN using the cosine rule. I am given this angle. I have this side as well as this side. So it means that I can calculate MN using the cosine rule. So I'm going to say MN squared is equal to MO squared plus ON squared minus 2. The MO multiplied by the ON multiplied by the cos of the given angle, which is 63. So mn squared is equal to, I'm just going to substitute, what is MO? MO, it's 25. ON, that's 37. Minus 2. MO, it's the 25. And then ON, it's the 37. Multiplied by cos 63 degrees. Mn squared is equal to, let's calculate 25 squared plus 37 squared minus 2, 25 multiplied by 37 multiplied by cos 63 degrees. So the answer is 1154 comma 118. Did I capture this correctly? Yes. So we take the square root on both sides so that we get mn. So square root of 1154.118. The answer is 33972 meters. So this is the answer for mn. Now how do I okay, by the way, we now have this. Mn to be 33.972 meters. Now they want us to calculate what? Angle N. Unfortunately, I do not have angle M, so I cannot use the sum of angles in a triangle. So what do I have to do? I'm going to take this divided by the sine of this angle and use this and the sine of its opposite angle to calculate what? N. So that means we are applying sine rule for number 2. So I'm going to say the unknown sine of n over 25 is equal to the sine of 63 degrees over 33,972. Doing a cross multiplication, you're going to have a sine of n 25 multiplied by sine 63 degrees over 33.972. Then sine angle n is equal to 25 multiplied by sine 63 over 33.972. Answer 0.656. Then the arc of that decimal, arc sine of 0.656. Answer, it's 40.996 meters. It's an angle, so it's degrees. Now calculating the last question, angle M, you're just going to use sum of angles in a triangle. So this is how you apply the first two rules, the sine and the cosine. Let's jump onto the last rule, the area rule. Okay, the area rule. So the area rule is somewhat like similar to the cosine rule. Okay, so when you are given maybe angle C, if you are given angle C, the sides between or adjacent to this given angle should be given. If you are given angle B, you should be given C and A. If you are given angle A, you should have the side C and B. So maybe we can start with this one. So let's say they want us to calculate the area for the shape. So the area is going to be equal to, using the area rule, it's going to be a half multiplied by the C. Remember, this is the given. So I'm gonna say half, area is equal to a half of B multiplied by C multiplied by the sine of the given angle A, or say there's an instance where you are given C. So the area is going to be calculated as half of this side, which is A, multiplied by this side, which is B, multiplied by the sine of the given angle, which is C. Or you are given, maybe let's say this time around you are given B, so it's just going to be a half multiplied by this multiplied by this multiplied by the given the sine of the given angle B, right? B. All right, let's apply this one quickly. Say maybe we have a triangle that looks somewhat like this, A, B, then C. I don't know, maybe we have a 30 degrees here, then a 4 and a 7. I'm just making this up, centimeters. Then they want you to calculate the area for this shape. So it's gonna be what? Area is equal to half of 4 multiplied by 7 multiplied by the sine of the given angle, which is 30 degrees. So the area, it should be 1 over 2 multiplied by 4 multiplied by 7 multiplied by sine 30 degrees. Answer, it's 7 centimeter squared. So this is how you apply the rules, right? This is how you apply the rules. You know what, just maybe as a bonus, let's have a right angle triangle. I just want to make a point here. We have 4 and 3. We have 4 and 3. 4 and 3. So in a right angle triangle, an area is calculated as area just half times base times the height, right? So this formula for finding an area in a triangle, it only applies to a right angle triangle. Or let me say the base and the height should always be perpendicular, then this formula can apply. Let's apply it here. 1 over 2 multiplied by what? B. The base is 3 multiplied by the height, which is 4. So the answer should be 2, it should be 6 centimeter squared. Now applying the area rule to this problem, we should get the same answer. Area is equal to half of what? 4 half of 3 multiplied by the sine of the given angle. The given angle in this case is 90 degrees. When I punch this, a half multiplying a 4 multiplying a 3 multiplying a sine 90 degrees, it gives me a 6 centimeter squared. This is what I have as my answer. You know what, I'm gonna create another video where I tackle some much more advanced problems, applying of course the sine, the cosine and the area rule. So for now I'm just gonna wrap it up. This discussion, it dragged this video a bit longer than I wanted to, but yeah, you know what guys, I'll catch you on the next one. Check the description box. I'm gonna leave a link for a video where I'm tackling at least one problem, advanced problem, where I apply the sine, the cosine and the area rule. You know what, I'm gonna catch you on the next one. Peace.